Alright, so welcome you guys. Today we'll be talking about inverse functions and relations. Okay, inverse functions are like inverse operations, except you're going to be dealing with a whole function instead of just the inverse operation. So the inverse of positive or adding is subtraction, the inverse of timesing is multiplying, or timesing is dividing, the inverse of squaring is square rooting, so on and so on. That does help you when you're trying to find inverses later. But when you are just trying to take a look at it, and ignore these two graphs, okay, your inverses, y equals 3x minus 2, okay, your inverses are going to be symmetrical over the y equals x line. So y equals x, okay, alright, 1, 2, x plus 2 divided by 3. Okay. Alright, so now just taking a look at this, here are two functions that are actually inverses of each other. Y equals 3x minus 2 and y equals x plus 2 divided by 3, the whole function. Now, as you can see, they're symmetrical over the y equals x line, and they should intersect at the same point on the y equals x line. So they should intersect at the same point. So if this yellow graph intersects over here, then the red graph, if it's truly an inverse, will intersect over there because it's a mirror image. So that's one way of checking it, is by doing it graphically. Okay, now if we actually had to do it by hand, okay, what you're going to do first is take your function and solve for x. Okay, now this is how to find an inverse. And step number 2 is change f of x and x, and you have f inverse. So of x, and this is how you write the inverse of something, is you're going to have f inverse. Alright, now if you wanted to check it, check it by doing compositions. If you go f o f inverse of -1 of x, and you get x as your answer, and if you do f inverse o f of x, in other words, if you take the function and plug it into the inverse, and you take the function and plug it into the inverse, and then you take the inverse and plug it in the function, you get x each time, you have inverses. Graphing's a lot easier, but if you're doing it by hand, this is just a good way to do it too. Okay. Okay, so to get an inverse function, you just work it like that, and that's just to check your work. So let's say we had a function f of x equals x to the parentheses, let's go parentheses, x plus 3 to the third, yeah, let's do third, minus 5. Okay, so what we're going to do is solve for x in this case. So I'm going to add 5 to both sides. So I get f of x plus 5 equals x plus 3 to the third. Okay? And then what I'm going to do is I'm going to cube root both sides. Cube root, do I have it? No, I don't. Shoot. Well, no, I do. Alt 0179, Alt 251, cube root of f of x plus 5 equals x plus 3. Okay? So you do that, and then you go down here, so Alt 0179 alt 251 of f of x plus 5 minus 3 equals x. Now once you get x there, you can just switch the two around, and now you have alt 0179 alt 251. Now you just switch the x and the f of x, and so you get x plus 5 minus 3 equals f inverse of x. Okay, and this will be the actual inverse of our function f of x. Okay, so once you do that, just change it, and you've got your answer and stuff. Now, if you did want to check it, I'm not going to check it because that's pointless. I know I did everything correctly. If you did inverses correctly, you will have done the inverted operation for each part. Okay, so please understand, you want to take your time on this stuff, and you just want to work through it very carefully, okay? All right, but that is pretty much it for finding inverses. Just remember, use your graphs, use everything you've got to get this stuff down, because it's going to be really easy to work with. Okay, but take your time with inverses, just finding them. It's going to be the easiest. And then I would check them by graphing them, just to make sure that you did the actual graph. And if you did, you'll see the symmetry there. Okay. All right. Thank you guys very much, and have a wonderful day. Bye.